Imagine for a moment that you are standing on the surface of Mars. The view is spectacular, a desolate, ochre grandeur that humanity has dreamed of touching for centuries. But there is a silent, invisible violence occurring all around you. Without the comforting embrace of Earth's magnetosphere or the thick blanket of our atmosphere, you are being bombarded. Galactic cosmic radiation, high-energy protons and heavy ions stripping through the vacuum of space at nearly the speed of light, is tearing through your spacecraft, through your suit, and eventually, through you. It doesn't hurt, not immediately. You don't feel the double-strand breaks in your DNA. You don't feel the cellular machinery misfiring. And while you might have a dosimeter clipped to your chest, a piece of sophisticated electronics logging the sieverts and grays, it is just a number on a screen, distinct and detached from your physical reality. But what if your clothes could feel it for you? What if the sleeve of your spacesuit acted like a second skin, bruising or fading in real time to tell you, instinctively and visually, that you have stayed outside too long? This isn't science fiction. This is the bleeding edge of biotechnology, where the University of Glasgow is colliding with high-end fashion design to create the Pigmented Space Pioneers. Welcome to Dr. Evolution's Toolbox. As a medical doctor and synthetic biologist, this podcast is where I share tools we are using to build a better world with biology. As a disclaimer, nothing I say should be considered medical advice. This information is for educational and entertainment purposes only, and these are my views alone and do not necessarily reflect the views of my employer. This podcast is supported by Brain.fm. Between studying medicine, reading patient charts, analyzing hundreds of articles, and preparing for flight test, my ability to focus is my superpower. But in today's world, entering that flow state can feel impossible. That is why I was excited to find Brain.fm. Their evidence-based, neuroscience-engineered music locks me in. They have several peer-reviewed articles funded by the National Science Foundation to back their results. If you're trying to build a better world with biology, why not use science to improve your life? You can start for free with a 30-day trial by using the link in the show notes. Now back to the show. We are talking about a project that fundamentally reimagines the interface between biological life and the hostility of the cosmos. To understand why this matters, we have to look at the Mars problem. As a physician, I look at space travel not as an engineering challenge, but as a physiological one. We can build rockets that get to the red planet. That's physics. Keeping the meat sack, the fragile human organism, functional upon arrival is an entirely different beast. Deep space missions expose astronauts to radiation levels that are exponentially higher than what we experience in low Earth orbit aboard the International Space Station. The cumulative effect is terrifying. Increased risks of solid tumor cancers, central nervous system damage, and acute radiation sickness. Current monitoring technology is reactive. You check a device, you download data. It requires power, it requires calibration, and most importantly, it requires attention. In a crisis situation or during a long EVA, extravehicular activity, cognitive bandwidth is precious. You don't want to be checking a gauge. You want situational awareness that is as intuitive as looking at your own hand. This is where the genius of the Pigmented Space Pioneers lies. The team, led by Dr. Giels Beilich and fashion designer Katie Tubbing, ask a radical hypothesis. Could we bypass electronics entirely? Could we use biology to monitor biology? Their solution is elegant in its complexity. They aren't using synthetic sensors, they are using bacteria. Specifically, they are utilizing 6 distinct non-pathogenic bacterial strains. Think of microbes like Serratia marcescens. To a clinical microbiologist, Serratia is an old friend, or sometimes a foe, famous for producing a brilliant blood-red pigment called prodigiosin. In the wild, these bacteria produce these vibrant pigments, reds, yellows, pinks, blues, as a defense mechanism against environmental stress. The researchers have developed a method to harvest these pigments. They are embedding them into fabrics using specialized needles and advanced 3D printing techniques. Now, it's important to clarify the mechanism here because it's fascinating. We aren't talking about wearing a suit of living, multiplying bacteria that could infect an astronaut. The process involves applying the microbes, allowing them to deposit their pigment into the textile matrix, and then the bacteria die off. What remains is the chemical ghost of the organism, the pigment itself, locked into the fibers. So how does this become a radiation detector? The mechanism is analog. It relies on the fragility of complex molecules. When high-energy radiation hits these bacterial pigments, it shatters their chemical bonds. It degrades the molecule. As the structure breaks down, the color saturation drops. The vibrant red of the Ceratina pigment begins to fade. Dr. Bialik points out a profound parallel here. The way radiation destroys the pigment is chemically analogous to how radiation destroys human DNA. The fabric is essentially a canary in the coal mine. If your sleeve is losing its color, your cells are likely sustaining damage. It creates a direct, visceral link between the invisible threat and the visible world. No batteries required, no circuit boards to fry in a solar flare, just pure biological cause and effect. We are currently in the proof of concept phase, but the timeline is aggressive. The team isn't just testing this in a lab in Glasgow, they are sending it to the ultimate proving ground. In February 2026, samples of this biofabric will launch into low Earth orbit aboard a pocket cube satellite called Spinning 1, developed by the Edinburgh startup Spinning Around. Picture this, a miniature satellite tumbling through the vacuum, carrying swatches of bacterially dyed fabric. Onboard cameras will watch these swatches for months, documenting the fading process as the cosmos beats down on them. This data is going to be the gold standard. It will tell us if the dye holds up against the vacuum, the extreme temperature swings, and the relentless radiation of space. But let's bring this back down to Earth for a moment, because while Mars is the dream, the implications for our home planet are staggering. As a physician-scientist, I am always looking for the dual-use potential of high-end research, and this project is a goldmine. First, consider the medical field. I've spent time in radiology departments and catheterization labs. Interventional cardiologists and radiologists wear heavy lead aprons and small dosimeter badges. But again, those badges are reactive. You send them to a lab, and a month later you find out you absorbed too much scatter radiation. Imagine instead medical scrubs dyed with these radiation-sensitive bacterial pigments. A radiologist could look at their forearm at the end of a procedure and see a slight fade, a visual cue that says, okay, that's enough fluoroscopy for today. It empowers the clinician with immediate data. Then there is the public health angle. Skin cancer is a global epidemic, largely driven by UV exposure. We are terrible at judging how much sun is too much. We apply sunscreen, we forget, we burn. Now imagine a t-shirt for your child dyed with a UV-sensitive bacterial pigment. As the UV index accumulates, the shirt changes color or fades, signaling that it is time to get out of the sun. It transforms clothing from a passive covering into an active health device. Furthermore, we have to talk about sustainability. The textile industry is one of the largest polluters on the planet. Synthetic dyes are petrochemical nightmares, poisoning water tables from Bangladesh to China. The Pigmented Space Pioneers are proposing a biodegradable, biological alternative. We are trading toxic sludge for bacterial fermentation. It is a glimpse into a future of biomanufacturing, where we grow our materials rather than synthesizing them from oil. However, I must temper this excitement with a rigorous look at the limitations. We have to be honest about what we don't know yet. Right now, we lack the hard quantitative data. We have the concept and we have the mechanism, but we don't have the dose-response curves. We need to know specifically how many grays of radiation cause a 10% reduction in color saturation. Is the fading linear or does it happen all at once? Does it respond differently to gamma rays versus heavy ions? Without these p-values and confidence intervals, it's a beautiful art project, not a safety device. The orbital tests in 2026 are critical to filling this data vacuum. We also need to address stability. Space is not just radioactive, it is a vacuum and it is thermally chaotic. Can these organic pigments survive the physical stress of launch and the thermal cycling of orbit without degrading from non-radiation factors? If the fabric fades because of heat, it creates a false positive, and in the safety system, a false positive can be panic-inducing. And of course, there's the biological safety aspect. Even though the bacteria are dead, we need rigorous biocompatibility testing. If you are going to put this inside a spacesuit, a sealed, humid, pressurized environment for 6 months, you need to be absolutely certain that the degradation products of these pigments don't cause contact dermatitis or allergic reactions. The skin of an astronaut is their first line of defense. We cannot compromise it. But these are the hurdles of all great science. They are the questions we ask on the way to the answer. What truly captivates me about this project is the philosophical shift it represents. For the last century, our approach to conquering nature and space has been industrial. We built thicker metal, faster chips, harder plastics. This project suggests a different path, a symbiotic one. It suggests that to survive the harshest environments in the universe, we shouldn't just rely on silicon and steel. We should look to life itself. We are entering an era of vibe coding our reality with biology. We are moving towards a world where our materials are responsive, where our environment communicates with us through the language of nature, color, light, and change. rather than the language of machines. The Pigmented Space Pioneers are weaving a future where our technology doesn't just protect us, it speaks to us, it warns us, it bleeds for us so that we don't have to. And as we stand on the precipice of becoming an interplanetary species, that might just be the kind of innovation that keeps us alive in the great dark beyond.